All right. Hello, everyone. Good morning, good afternoon, good evening. Thank you for joining us from wherever in the world you are today. My name is Royston Lobo, and we're at the MuleSoft online meetup. So this month, we have the pleasure of having Stephen Yu join us to talk about exposing our APIs in Runtime Fabric. Stephen is a loyal presenter at the online meetup. This is his fourth presentation now, so a huge thank you for Stephen for taking the time to prepare this presentation and deliver it as well. Just as a reminder, if you have questions or comments during this presentation, you can add your comments into the chat window, which is on the right-hand side of the screen. If you have any questions, I've pasted in a link in the chat for your Q&A link. Attribute that your questions to that link as we go along. The slides and the recording from today's session will be uploaded onto the event page within 24 hours, so you can use it as a reference later on as well. A reminder that all our events are posted again on the online group for the online meetup. If you subscribe to the group, you will be notified when we have future events as well, even at the events in the other time zones like EMEA and America. So with that, I'll pass it on to Stephen. Stephen, please take it away.
Thank you, Rustin. And thank you, everyone, for joining us today. This is Stephen Yu. I'm based in Sydney. Today, we are going to talk about the guide to expose API in RTF. Runtime Fabric RTF is a platform to host and manage APIs. And we also need to expose the API either internally or externally to consume these APIs. So this is one of the areas we often see the problem and the questions. So this session will go through the whole picture about how to expose API in RTF, as well as a lot of details which give you a deep understanding on this topic, and hopefully it helps you smooth the experience in using the API. So you should be able to see a banner on top of each slide, so you can post your questions during the session. We will have a Q&A in the end. I'll try to answer as many questions as I can. And we also have collected some questions before this event. I go through these questions during the session. All right, so without any further ado, and let's get started. So first is safe harbor information for you to read. And just a quick myself, I'm Stephen Yu. I have been working in the MuleSoft support for 3.5 years. I have DevOps and consultant backgrounds. I used to helping a lot of customers migrating to AWS and build the CI/CD pipeline. My specialty is cloud, especially in AWS. I'm a certified AWS professional and specialty. I also have the Kubernetes certifications. My work used to help customers on the platform side, help customers design and troubleshooting the connectivities. And then now RTF is one of my major focus areas. I'm the specialist in the team. So speaking about RTF, RTF is a flagship product. It leverages cutting-edge technologies, the Kubernetes. It containerizes applications and platform built on top of Kubernetes. It's like a small scale of cloud in your hand. It brings us a lot of flexibilities, and this is also comes with a price. So first, you need to manage and maintain the containerized platform. Recently, I have a couple talks about RTF. The first meetup this year, I talk about RTF upgrades, because keep the platform up to date is recommended, but also challenging sometimes. It involves 3 upgrades, and the appliance upgrades is most challenging one. And the second is manage and deploy APIs. RTF is an API platform which is used to manage and deploy your APIs. The RTF deployment is one of the hot areas. We see questions, queries, issues. And in the second meetup, I talk about RTF deployment and the theory behind the thing, the CPU memory, some common problem, and tricks in troubleshooting issues. These 2 sessions are recorded. If you are interested, you can go back and watch the video. So the third challenge is expose API, and this meetup is about this topic. So the agenda today, we will first introduce the high-level RTF architecture and different layers in the RTF. Then we introduce how a request is routed to the applications. We will touch the Ingress, give give a touch on the Flannel, the overlay network, and have an brief introduction about certificate managers, external load balancer, use API-wide policies in RTF, and the routing upgrades, and then the troubleshooting guide. And these, we often see the problem on these topics. So I hopefully it can give you some knowledge and experience, help you in the RTF. In the end, we will recap and open the Q&A session. So you can just put your questions. You can see the link or the link also in the chat. We will answer in the Q&A session. So, all right, about RTF architecture. So RTF is a platform to manage and deploy your APIs. It's based on the Kubernetes. Okay, let's check from bottom to top. The bottom one is a Gravity layer, and then the Kubernetes layer, RTF runtime. On the top, we have the applications. And that's our goal. We want this platform to deploy our applications. So why we use Gravity? So we deploy containerized applications to RTF. We use containers because it's lightweight. It can keep a consistent environment. It can run everywhere. But before we can do that, we need to establish a containerized environment. It's not an easy job to get this Kubernetes environment up and running and keep upgrading. So let's push the containerized mindset further. So we can have a containerized runtime for the application. Why not we have containerized environment for the Kubernetes? Yes, that's Gravity. Gravity is a container for the Kubernetes environment. It's like a consistent bubble holding all the required service as well as a Kubernetes environment. So once we install Gravity, it holds all these components, get the Kubernetes environment up and running. In the Gravity layer, so first layer, the bottom layer, we have some low-level services like LCD, Flannel, DNS, systemd, Planet, Teleport, and these are all low-level services required by the Kubernetes services. So then on the second layer, from bottom to top, second layer, we have the Kubernetes API, Kubernetes control managers, and this is a Kubernetes services. And we have some Kubernetes basic service like DNS and monitoring. So with these two layers, we have established Kubernetes environment. And then we install the RTF components. We call it RTF runtime environment. In this layer, we have the agent, Ingress, resource cache, and all these are required to manage and deploy your applications. Like the agent is a component keep communicating with the control plane. So once you put an option on the control plane on the console, it gets the command and execute in your cluster. The Ingress is about exposing the APIs, and then the registry creds is refreshing the credentials to the image repo. And with all these three layers, we have established RTF environment. So we can deploy the APIs. And from RTF 1.8, we released the Buy Your Own Kubernetes RTF. Or the formal name is called RTF Runtime on Self-Managed Kubernetes. So in the BYOK RTF, Bring Your Own Kubernetes, BYOK RTF, the bottom two layer is not included. So we focus on RTF runtime and we focus on the new APIs. And these bottom two layers are delegated by you. You can install it either in the AWS EKS or in the Azure EKS, right? Has all these managed Kubernetes environment and owned by you. There are pros and cons in this. So we don't provide a Kubernetes environment, so you will need to manage it, right? There's some overhead, but still the majority of the management operation is done by the vendor, by AWS or by Azure. Still, you need a couple of things. One thing is like Ingress. We don't provide Ingress in the BYOK RTF, so you need to install the Ingress, and that is used to expose the API externally. And this brings a lot of flexibility. And for example, an RTF is a dedicated platform, dedicated Kubernetes platform. You can't put your application in this Kubernetes environment, and these applications share the same environment, but it can't be shared with other applications. But in the BYOK RTF, you can install the RTF in your Kubernetes environment. And that means Mule applications can share the same Kubernetes environment with your applications. This gives you a lot of flexibilities and can share more resources. But still, you need to manage. You need to take some management responsibilities, like to set up the ingress, set up the log folders. Okay, this is about the RTF architecture and about 3 layers from bottom to top. We call it gravity layer, Kubernetes layer, RTF runtime, and with all the layers, we have the applications runtime environment. And in the BYOK RTF, we don't have the bottom 2 layers. We only install RTF components. And in the RTF component, we don't have the ingress and log folder. You need to use your own. And based on top of that, it's still the same, run the same new applications. All right, so we received a couple of questions and in the pre-survey, so I think it's a good point to answer these questions now. The first question is about how to recover the real CPU usage of the application deployed in the RTF. And this is meant to check the license compliance. I need to automate a method in order to restore the information in case of similar and exploit information. So currently, and this is the formal recommendation is go to the Open Center and check the CPU code usage in the Open Center monitoring console and get from there. As there's no API to expose monitoring metrics. But however, we see some customers is get these metrics from the sidecar. It's called endpoint monitoring sidecar container. So in each application, there are 2 containers. There's one called application, and the other one called endpoint monitoring. It's a sidecar container. The sidecar container is check the metrics from the application and stream the metrics to the control plane. And while streaming the metrics, it also print out these metrics in the logs. Once you forward the log to your log server, you can get all these JSON strings. And a couple customers try to read these metrics and use it for alerting and for like the license compliance. But still, I would say, and this is a formal recommendation, and we would like to hear from you in the idea portal. If you, this is really good example and use case, you can put your ideas in the idea portal, and the product team will take it into consideration in future. So second question, if you can give some brief about RTF, then it would be great. Thanks. Yeah, this is about the previous slide about RTF architecture. Third one, how to enable auto scaling on API deployed to the RTF is a such feature to configure auto scaling based on some rules. Unfortunately, this is it's kind of not available, but we do see this is on the roadmap. Please put your ideas in the idea portal so the product team can take it into, can prioritize these features. So what is RTF deployment? Is it related to deploy in Cloud Hub? So RTF deployment is about deploy the RTF, deploy APIs to the RTF, and the operations involved in this deployment. And as I mentioned in the last meetup, I have one meetup focused on the RTF deployment, and this is have in-depth content in it. I would recommend you check it out. So when to use RTF? Well, this is a big question. I think it's better to check with your sales team or pre-sales team, because each customer got different situations. This will depend on your company compliance and your roadmap and also your level of operations. So in general, I think this is asking like a question. We have a Cloud Hub, RTF, and PCE. So which product should I choose to deploy the new applications, right? So Cloud Hub is like everything in the cloud. And the PCE go to another extreme, put everything on premise. And RTF sits in between. They have the runtime on premise, you can own it, brings a lot of flexibilities. They have a control plane still on the MuleSoft side. So in this case, like you can avoid some limitation in the Cloud Hub. In the Cloud Hub, we don't support like a transit gateway. It's on the roadmap, but not support yet. And But if you can deploy RTF in your environment, you can just leverage all these kind of features. But still, it's a good question to discuss with our pre-sales team and the professional services team. It will give you a better answer according to your situation. Last question. Schedulers are not available in RTF environment. When are they planned to be available in RTF? I don't have a good answer to this question. I know the scheduler is available. It can be configurable in the Cloud Hub, but it's not in the RTF. It's not exposed to the RTF environment. So RTF basically is catching up a lot of features in the Cloud Hub. So you can put your ideas, or you can find similar ideas. You just put it up. So our product team can prioritize this feature according to the feedback. All right, so this is about pre-survey questions, and let's go ahead. So now let's check how a request is routed to the application externally, right? This is about the main topic about this meetup. Let's check from left to the right. So a request coming, we require a first hit is customer load balancer. In the RTF, we require to have a customer load balancer in front of an RTF cluster. And you can also use, like, if you deploy on-premise, you can use F5 device. If you deploy in the cloud, you can use a AWS or Azure load balancer as an external load balancer. So the request hits the load balancer, and the load balancer will route the request to the one of the Ingress node. And Ingress gets the request. It checks the host header, checks the path, and then map to the application. So from Ingress to the application, so I highlight in this diagram the Flannel because it's a cross-node communication. We'll talk about the Flannel in a minute. Basically, we need to keep this in mind because in some old version RTF, the Flannel, the overlay network, causing issues. And this issue was fixed, but still some customers are in the old versions. So the Ingress will redirect the request to the application, and this is cross-node communication where pass the overlay network Flannel, and then hit the application on the port 8081. Right. So in the Cloud Hub, if you got experience in the Cloud Hub, you will see that HTTP on port 8081, HTTPS on port 8082. But in the RTF, they're both on 8081. Then the last mile security. The last mile indicates the communication between the controller and the worker nodes. Since the controller and worker nodes are supposed in a secure environment, usually we can just use HTTP, but some organization has a security compliance, like us, encrypt all the way down to the application. So in that case, you need to enable the last mile security. That means you use HTTPS between the Ingress and the application. Still, it uses port 8081. Okay, so this is about how requests come to the application. First hit the load balancer, the Ingress redirect according to the rules to the application on port 8081. If we have an external request coming this way, but how about an application talk to another application inside the same cluster? You can still use the same way, like a user and one application. Let's, for example, this diagram. If the application above want to talk to the application below, right? You can still use the same way. You can send this application, send the request out, first hit the customer load balancer, and then come back Ingress, and then come to the application below. But there's a better way to do that. And in that case, the path is relatively long and cause overhead to the system. We can do it just to use a service endpoint, which is created by the Kubernetes. So if both applications are in the same namespace, we can just use an application name. Okay, if you want to call application called Hello World, just use the name and to hit the application. But if the destination is in another namespace, use a name.namespace as a host name. So we use the environment ID as a namespace ID in the Kubernetes. So when you want to hit from namespace 1 to namespace 2, you need append the namespace ID. Like in this example, hello world dot the long string is about the environment ID, and you don't need to put the external domain. You can hit the applications. And this is why you can use this way. Actually, this is Kubernetes features, and the BYOKRTF has the same kind of behavior. In the Kubernetes, each time when we deploy an application, create a service endpoint, it will create the DNS domain, local DNS domain for us. And that local DNS domain is resolvable inside that Kubernetes cluster. So when application is deployed, we can see the search domain. Actually, it's first search the hostname inside its own namespace, then go up level until go to the itself. So if we use application in the same namespace and it first appends the first search domain to it and find the IP address and go for it. If it's in a different namespace, it will go to the second search domain and find the IP address. If you use external search domain, search all these domains and can't find the IP address, then search itself and then find the IP address. So this is why we can use this way, and it's a Kubernetes feature. BYOK also has this behavior. So about Ingress, a little bit about Ingress. Ingress is part of the RTF components. It's owned by the MuleSoft. It's about MuleSoft developed Ingress. If you use RTF Ingress long before, it's time to refresh your knowledge. The Ingress is improved a lot this year. So Ingress by default is installed with other RTF components on controllers. It's called a shared mode. Now you can install it on a dedicated mode. So that means it install on a dedicated nodes separate from the controller nodes. And in that case, we can just have a serve high volume traffic, right? Don't interrupt the components, RTF components. These components keep connecting to the control plane and has other functionalities. So we have dedicated nodes, so we have some high volume of traffic. But still, the dedicated Ingress node is considered as worker nodes. The maximum number of worker nodes support is 16 nodes. The Ingress, when we first released the Ingress and for a long time, it only support HTTPS, and now it supports HTTPS and HTTP. And it makes sense because after the customer load balancer, we consider the environment is an internal environment. It's secure, so we can use HTTP. In that case, if you don't have security requirement, actually we can just use HTTP. It has a less overhead to the system, and the Ingress can serve more higher value volume of traffic. Then the last mile security, as I said, is on port 881. Then the Ingress has advanced options. These advanced options usually has default value we fit for most of the scenarios, but in some extreme cases, you may need to adjust these values to fit your case. If like I put to know the article in this slide, if for example the payload is very large and takes more time to read from the application, then you need to adjust the timeout, read timeout in the advanced option. Like another thing we see from a customer case is if you see the many connections try to connect to the Ingress node, it might exceed the maximum connection limit. In that case, you will see the 500 internal server error and could not create upstream connection. And in the case, you need to go to this advanced option and raise the maximum connection to a high limit. And these articles, you can just search in our help portal with all these keywords. You will hit these articles straight away. So how Ingress and Inbound finds applications? What's the magic behind it? And actually, it's very simple. So when we deploy an application, and the application need to create the service endpoint and also create a one called Ingress resource. And in this Ingress resource, it just has a bunch of mapping rules. And the ingress, check all these ingress rules, find the one match to match the request and send the request to the applications. For example, right, let's check one of the ingress resource. You can use Kubernetes get command and check the details. And we can see in this one, the host header, the host need to match rtf.mulesoft.com. And the path need to match /demo app2. So if this host header and the path matches, it will forward the request to the service is called name demo app2 on port 8081. Right? This is how it works. So when the request comes in, the ingress checks the host header, checks the path, and then do a global search in all the ingress resources and find the ones matching and send to the applications. If none is matched, none is matching the request, it just gives back the 400 error, 404 error. I can't find the applications. And also for these reasons, the application cannot have the same name in the same cluster because Ingress is doing a global search in the whole cluster. If you have the same name in different name, even in different namespace, and it will confuse, the Ingress will get confused and can't find the right applications. And also we see an issue which customer is randomly received a 502 bad gateway response in the RTF. And because for some glitch, networking glitch, when the application is deleted from one namespace and deployed to another namespace, the ingress resource is not fully cleaned up. So the ingress is got confused with two same name ingress resource and can't find the right application. It is called the intermittent 502 bad gateway response. And in the BYOK, is basically is ingress follows the same mapping rule. Just is a slight different is in like if you use Nginx as the ingress in the BYOK RTF, the mapping rule need a little bit tweak. Apart from the path mapped to the application, the remaining part you need to specify, you need some regex to specify to map to the applications. Otherwise, all these will be left. But in the RTF, we just make it default. You don't need to specify. We don't need to specify this regex. It will keep the remaining path and forward to the application. There's a slight difference here. All right, so the Flannel. Flannel is actually a very deep networking topic. In Kubernetes, all pods are able to freely communicate with any other pod in the cluster, even they are in a different host. Right? You can see the pods and service. Actually, they're running in a completely different CEDAR range. So why they can do that? So actually, it's because it has a overlay network layers. For example, right, in this diagram, if the pod 1 wants to talk to pod 2, just go via the dock bridge and talk to the pod 2 directly. If pod 1 wants to go to the pod 3 on another node, at first go via the dock bridge and then go to the Flannel. What Flannel does is just wrap up these packets. I wrap it up, and then use UDP send to a port on the other host. The port is by default is 8472. And then on the other host, the Flannel unwrap these packets and find the port IP address and send the request to that port. So when we do the cross-node communication, the Flannel always comes in the way. So what's important here is ingress on the controller and or dedicated mode, while applications on the worker node. So from ingress to the application is always a cross-node communication, and Flannel gets in the way. And in the old version of RTF, the Flannel got a problem. The MAC address can't be refreshed because some etcd issue, and we have fixed this issue in the new version. But still, if you are still in the very old version, like the version older than the August this year, 2020 August, or last year, when you see the issues you need to check with this script. I put in the title how to check if the overlay network is working well in the RTF. Search in the help portal, it gives you a script, and we check the Flannel and check if the MAC address is correct and print out the result. The certificate manager in the secret manager. So you can upload the certificates directly, but it's also recommended to use the secrets manager to manage the certificates. So you can import the certificate from the secret manager. The steps are straightforward. So here just 2 tips we see from the past cases. So one is if you want to use a client certificate, there's only one place to upload the certificate. If you want to have multiple client certificate, what you need to do is just put multiple client certificate in one file and upload from there. And then if you have multiple domains, and previously, what we can do, you can only use the same multiple same name, subject alternative name in one certificate and support multiple domain name. And now it support multiple domain names in the Ingress. So we got 2 ways. Either you can use multiple domain name provided by Ingress, or just use multiple SANs in the same certificate. 2 options for multiple domains. Then the quick touch on the external customer load balancers. External customer load balancer is required to expose the APIs externally. And this is the request first hit point, and then it needs to redirect request to Ingress in the RTF cluster. And this load balancer can do the health check. Is TCP or SSL. HTTP or HTTPS is not, usually it's not supported because it requires a host header. As we see before, if you want to route the request to an applications, the host header and the path need to match, and then can find the applications. Right? We can deploy a health check application, but still the load balancer need to set the host header. Most load balancer don't have this ability to set the host header, so HTTP or HTTPS health checker is not available in that case. Then we can use many different kind of load balancers, and for example, in AWS we can use a ELB and NLB, and we can use a TCP load balancer, which means the HTTPS is terminated on the Ingress node. We can also use the HTTPS load balancer. We can mean the HTTPS first terminate on the ELB and then encrypt and terminate on the Ingress again. So the second got advantage is in the AWS, you can get a free certificate from the ECM. So you can deploy this free certificate on the ELB, and then use some self-signed certificate in the Ingress. And firstly, it's free, and then AWS will manage the rotation of the certificate. So it's more convenient in this way. If you do the HTTPS load balancer, you need to keep in mind the AWS ELB upstream is use TS 1.1. And if you don't select TS 1.1 in the Ingress, it will cause issues. So you need to enable the TS 1.1 in the secret managers and then export it and then re-import in the Ingress. The Ingress will accept the TS 1.1 protocol. Okay, this is a quick introduction about the external load balancer. Okay, this is also an interesting topic. Use APIs policies in the RTF. In the RTF, you can see there are many load balancers. Once the client sends a request to the workers, their customer load balancer, Ingress. Ingress, you can consider it's kind of a load balancer. You can set the whitelist on the customer load balancer, or use the endpoint security to whitelist the IP in the Ingress. But still, and some customers are using the API policy provided in the applications. I think the reason is because it brings more flexibilities. It's the dev team just need to update some policies, can do the whitelist or blacklist. So it's more convenient. But in this case, so you need to be very aware. If you don't do it right, it might introduce a security risk. Okay, let's check the above diagram. So client got IP address, sent to request to the customer load balancer. the ingress, and on the workers application receive the request, it will check the X forwarded for header. It includes all the previous client IP address. If they follow strictly to the standard, right? We'll see this IP address. So if you want whitelist, right? The first impression, you want to whitelist the client IP address. You want whitelist the first IP address. You can use some DW expression, extract the first IP address, and use that to whitelist in the API policy. But this brings a security risk. Because this host header, or this X40 header, HTTP header, can be tampered. Like for example, if this client maliciously add a header, that's IP address 111, and then it send a request to the CLV and then pass to the application, the header will become the maliciously added header and then append with other IP address. If you use the first IP address, it might be just a template header, so cause issues. Can pretend to be that IP address, but actually it's not, because it's not guaranteed in the HTTP header. It's different from the TCP level. In that case, what you can do is we can trust what the customer load balancer put in this header, because it's in our control, right? What customer load balancer put in this header is actually the second to the last. You can see it's the actual client IP address instead of the IP address put by the client itself. It can be a template IP address. So in this article, how to apply IP address, IP whitelist or blacklist policy in the RTF, it introduces how to use DW expression to extract the second to the last IP address and use that as a whitelist, whitelist in your whitelist policies. So, and this is just the introduction. You can check the full details in this knowledge. But when you use API policy in the RTF, you need to be very aware. If you don't do it right, might be bringing the security risks. So next is about rolling upgrade. So rolling upgrade, when we deploy applications in the RTF and we do in a rolling fashion, and that means we create a new port, and when the new port is ready, we replace old ones. That's right. So during this process, it's designed to be zero downtime, but in the heavy request scenario, like if they keep a high volume request sending during you do the upgrade, I mean, I cause issues because the request is still served by the old port, and at the time and the old port is terminated and changed to the new port, the request is not finished, will cause some server-side errors to back to the client. And we have enhanced for the zero downtime, and this is enhanced in the runtime level in all the latest runtime. And if you, for some reason, if working some old version of the runtime, you need to request. So you send the case to the support, and we will ship the patch to that runtime. For this really zero downtime, you can test with some benchmark tools. Like one thing we usually do is just use HEI, and this very lightweight performance testing tools. You can set a lot request to it during the time. You can see still it received all 200 response. So if you use like a different, like an old runtime, you might see 500 or 400 errors during the cutover moment. But if you use all these latest runtime or these enhanced runtime, you will see 0 errors, and it will keep all 200 response during the time. That's about a rolling upgrade. And the next is about troubleshooting guard. So we talk about how a request is routed to the RTF from left to the right. So when we do the troubleshooting, when we see the issues in the RTF, what do we need to troubleshoot? We can troubleshoot from the right to the left. So first thing, we need to check the application is running, and then we need to check the cross communication is working. So what do we usually do? Just log into a controller node and do a curl to the service endpoint, right? This tests two things. The first, applications is working. And secondly, the cross-node communication is working well. If it works, means both are working. If it doesn't work, means either may have a problem. So in this case, you can log into the worker node and check if the port is working. If the port is working, and you check and send a request from another controller to the application is not working, means the Flannel got issues. This happened in the old version of RTF. Then you need to check with the script I put in the previous slide. I will check this Flannel and show you if there's a problem. So after this step, right, you log into controller, you send a curl request to a service endpoint, everything is working fine. That check gives us confirm the Flannel is working fine, the application is working fine. Then we go ahead. Then we can send a request to each ingress. We can still use curl command. You just put the host header and we route the request to the application. We send a request to each of the ingress node and check if all of them are working well. It might some of the node goes problem. So that's why we need to check all ingress node. So we check all the ingress, it's working well, means the RTF itself is working well. So next, what we need to check is customer load balancer. There are issues in the customer load balancer. It might send got some cache or send to the wrong header. In some cases, so the customer load balancer might bring some problem. So as long as we check all these, double check all these in the RTF cluster, then we can check the customer load balancer. The request sent from left to the right. When we troubleshooting the issues, we should do from right to the left. Check the application, check cross-node communications, check ingress, and check the customer load balancers. In check the ingress, you can check. Sometimes it's very rare. It might be has some duplicated ingress resource, and you can check search in with the Kubernetes CTL command if there are any duplications that might cause issues. And you can also enable one thing we usually do is we just enable the debug or trace log in the ingress. It will show us what error is, and then we can check next. To summary, we do the troubleshooting. We just do it from right to the left. We check the application is working, the networking is working. What you can do just to curl from controller node to the service endpoint. Then we check on each ingress. If it's working, then we put our focus on the customer load balancers. We check one step by one step. We will figure it out very, very quickly. All right. So I think that's pretty much about today. So let's have a quick recap. And firstly, we talk about RTF architecture. We have 3 layers, and in the BYOK RTF, we don't have the bottom 2 layers. That's a difference. And the whole request is sent to the application from left to the right, customer load balancer, ingress, and then the application. We touch on the ingress, how the ingress find the applications, and how cross-node communication is working. This part is a very deep networking topic. What you need to understand is the cross-node communication is one Flannel. It's one thing we need to check if you see the issues. Then we have a brief introduction about the certificate manager in secrets managers, some tips, how to use multiple client certificates, how to use multiple domains. We touch the external load balancer. Okay, we can use the health check, and also we can use 2 types of the load balancer, TCP or TTPS. And this is also a very tricky topic, how to use the API wireless policy in the RTF. If you don't do it well, it might have the security risks. So pay attention to this. Then the rolling upgrade, rolling update. So all the latest runtime is 0 downtime, rolling update. But if you are in the old version runtime, please request for it. And then last is the troubleshooting guide. The request sent from left to the right. When we do the troubleshooting, we just do it from reversed way, from right to the left. And then you can figure it out very quickly. All right, this is about the quick recap of the content today. Next is our Q&A time. Let's see how many questions we have.
Right, we have at least one question in there, or a couple of questions at the moment.
Okay, from Siri. Is there a way to enable blue-green cluster in AWS within the same region? Does your Terraform script support blue-green deployment? You might mean you have two clusters, like keeping in the active mode, and if one goes down, you can use the other one. That's my assumption. Yeah, some customer is doing this way. They just keep the DR cluster and the Pro cluster all up and running. They keep deploy the same application to both cluster and use a load balancer in front of it. And once one is done, you just can use another one. I'm not sure if it's what you mean by blue-green cluster. But in each deployment, we don't usually do that. So for each deployment, we use a rolling deployment. So we deploy to the same cluster, and we don't use deploy to the blue one and then test it and then switch to the green one. So most of customers just deploy applications to the environment in one cluster. And because it's a rolling fashion, if you update the existing applications, it won't cause any issues. If you deploy new applications, you need to test it and then deploy it to the production. And the Terraform script doesn't support that. Terraform script does a reference, give you an basic understanding of how to set up a cluster. If you want to have two active cluster up, you need to use this Terraform script twice, or maybe you need to modify something inside it to have these two cluster all together. So is BYOK, second question, is BYOK RTF currently available to client, or this is a future RTF offering? Yes, it's available, and it's after we release 1.8, so RTF has two choices. It's BYOK RTF, and also the RTF, the previous old RTF. So when you check the documents, you make sure you see the version. There's a URL, there's a version number in the URL. If you see like 1.7 or the old versions, you might not be able to see it. You make sure you replace 1.7 to the latest or 1.8. You will see the content. It's called customer managed Kubernetes. There's one section about it.
I've put a link into the chat for this managed Kubernetes as well. We had another
that's a document
question in the chat around the TLS 1.1 config, Stephen. Do you have any references on how to set TLS 1.1 within RTF?
The TLS.1 is set in the secret manager. In secret manager, you need to put your certificate in it, and you need to create a TLS contest. In the TLS contest console, you can select the TLS 1.1, 1.2, 1.3. You can enable both of them or just enable some of them. And also in that console, you can select the ciphers. You can select the ciphers, strong ciphers, or weak ciphers, or the cipher you support. So you just go to the secret manager and go to the TLS contest. You will see all these settings.
Looks like we don't have any further questions. Just a reminder for everyone, if you have questions, you can type them into the link I'd shared earlier. I'll just paste it in for your benefit. There. All right, we have a question on the chat just asking for a recap on the external load balancer. Stephen, would you be able to briefly talk about it?
Yeah, no problem.
And maybe you could provide a little bit of context with how that works with the BYO Kubernetes as well.
Okay, let's first talk about the old RTF. In the old RTF, we have the Ingress providing the RTF components. offer this ingress, but you need to put a customer load balancer. You can use, if you deploy in on-premise, you can use F5 or other devices. If you deploy in the cloud in the AWS or Azure, you can use AWS ELB or NLB or use Azure load balancers. So this load balancer, as we checked here in this slide, need to set up the health check. I currently support TCP or SSL health check. And with this load balancer, you can use a TCP load balancer. It just, in the AWS, you just pass through, right? Pass through the TCP, just on the TCP level, it just, the load balancing send the request to share the request to different ingress. Also, you can use a TTPS load balancer, means the TTPS is terminated on the load balancer first, and then we encrypt and decrypt. Then a new HTTPS will be terminated on the ingress. There are two HTTP sessions in between. In this case, and you can use a certificate from the ACM on the ELB, and also use a self-signed certificate on the ingress. So the out-facing is still third-party certificate, and inside between the ELB and the ingress, you can just use a self-signed certificate.
Thank you, Stephen.
Yeah.
We also have a question around cron jobs and scheduling verbally. So Siva says, I have plenty of cron jobs that pumps up data using Mule batch flows. Since RTF is not ready with schedulers, what is the alternative way to achieve this within RTF?
The RTF is don't have the scheduler configurable on the console, but you still can run it in the RTF, the scheduler in the RTF. The thing is, we can use a property or hard coding the cron expression into it, and it can just run as a normal scheduler jobs in RTF. But still, it's not as convenient as in the Cloud Hub. It's not available in the console to configure this cron expression, and this is in the roadmap. You can also put this idea in the RDA portal, and the product team will prioritize this task.
Just to confirm, Stephen, it's not currently available in Ops Center as well. Is that correct?
Ops Center is about a cluster. It's not about applications. Ops Center doesn't have this option.
Okay, that's good to clarify.
No problem. Thank you. So when will RTF become compatible with RTF Red Hat 7.9? Yeah, this is a good question. RTF is compatible with up to Red Hat 7.8, then Red Hat 8.1 and 8.2. It's designed to be available in the next appliance release, probably this month. By the end of the month, we will have another release that will support Red Hat 7.9. But still, and as you might hear, there's a secret memory leaking issue. There's certain secret memory issue in our help portal. And this issue exists in all Red Hat 7, also Red Hat 7.9. It's not fixed. From current testing, we did a comparative testing. I have Red Hat 7 and Red Hat 8, and it seems that issue is fixed in the Red Hat 8. So if you can, I would recommend just go straight to Red Hat 8. You can use Red Hat 8.1 or 8.2. Use that RTF. You can avoid that secret memory issue because this is a very low-level kernel issue. It causes many other different issues, like in the upgrades, in the deployment, or in the Flannel issue. So if you can, just go ahead, go straight to Red Hat 8.1 or 8.2.
Even do you know if that issue is also CentOS equivalence of CentOS 7?
I think CentOS 7, I'm not really sure, but similar, it's equivalent. CentOS 7 is Red Hat 7. It's like the same structure, same kernel in the low level. So probably you still have the same issue.
Okay, it's good. I think it's good to have the advice that, if possible, go to Red Hat or RHEL 8 in the latest version that's supported. Excellent. All right. looks like we have no further questions on the Google questions link, and there's nothing more on the chat. So we'll take that as everyone is satisfied with what they've learned for today. So take that as a cue to close up. So Stephen, thank you once again for taking the time to put this presentation together. Really appreciate all the effort you've put in the 3-part series so far this year. And I'm sure there's a lot more to learn as well. For everyone in the audience, the slides and the recording will be made available on the event page within 24 hours. So keep an eye out for that. If you have any feedback or you want to say thank you to Stephen, please put that in the chat right now, or you can put it in the feedback survey that will go out shortly. We always look forward to listening to your feedback and see improve as well.
You're welcome. My pleasure. Thank you, everyone, for your time.
Excellent. Fantastic. And we have one more meetup in the online meetup coming up in a week or two. So just keep an eye out for announcements when that gets published. I wish you all a wonderful rest of your day.
Bye.